Welcome to May 16th LeetCode Challenge. Swap nodes in pairs. Given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list's node, i.e. only nodes themselves may be changed. So example number 1 here, we have the values being of the linked list being 1, 2, 3, 4, and we want to swap the pairs. So every two nodes are swapped. So 2 swaps of 1, 4 swaps of 3. Example 2, if we have an empty linked list, then therefore return empty as an output. If the linked list has one item or one node, then return that one node. Our constraints of the number of the nodes in the list ranges between 0 to 100 inclusive, and the value of the nodes are between 0 to 100. So the reason that makes this a medium question is because we have to switch the nodes themselves without changing the values, and that's kind of basically the intuition behind that is to swap the current node with the next node, then kind of recursively swap the remaining sublist. So by doing so, we ensure that every pair of the adjacent nodes gets swapped throughout the list. So to develop a approach to this, let's say that we have a base case that checks to see if the list is empty or contains one node, right? Check these two cases here. If there's nothing to swap, then the function returns head as it is. So let's do that. So the first thing we're going to do is check the base case. So if head equals null or head.next equals null. So basically if the list is empty or it has one node, then return head. Alright, that's the base case. So the next thing we want to do is we should probably... So the next part of the algorithm approach is if the list has at least two nodes, then the function proceeds to swap. It stores the next node as next node for recursion. So we should probably store the next node for recursion. So what we want to do is make a list node object called next node, and we store that as head.next. Next thing we want to do is, when we already store the next node, then we want to swap the current node and the next node. In order to do that, we basically swap it. So head.next will be the swap pairs, and we recursively call it pairs, and we pass it the next node, which we stored above, .next. So we swap that, and then we also have to update next node .next to be head. So we have to store the pointer to that. And then, so this is a swap, we recursively call it, but we also have to basically, at the end of the day, at the end of the function call, return the new head. So basically that means that the next node becomes the head after swapping. And that actually means that it is right here, right? And then we just return the head. Return head. Oh, return next node, I should say. Next node. Alright. This should run. Looks decent. Oh, sweet. So accepted. So time complexity wise, for the solution is big O of n, where n is the number of nodes in the linked list. Since you visit each node once and perform a constant amount of work on each node, the time complexity is linear. Space complexity wise, the space complexity of this is also big O of n, because in the recursive call, the function calls the stack to keep track of the intermediate results. In the worst case, the linked list is completely unbalanced, so therefore we have to call upon the maximum depth of recursion, which would be n, which contributes to the big O of linear time complexity. And that's it. Have a great day, everyone.